Go Language Programming, Chapter 5, Unit 5. In this unit, we will cover file processing in Go language, making of a file, streaming I/O in Go language, writes bytes to a file. So let's start. File processing in Go language. As we know, variables and arrays are used for temporary storage of data in internal memory or in the RAM. So basically, that means that since they are in the memory, as soon as you turn off your device, all the data that is used by arrays or variables will be lost. Okay, so for that reason, we need some way to be able to store the data permanently, and files have the capability of doing that. So files are used for a permanent storage of large amounts of data on a secondary storage device. So basically, to do the permanent storage, you need to have some device like a disk or a tape, or in nowadays, we use a memory stick to store the data which is located in a file. So files are organized for sequential or random access, also called the direct access. So you can move in within the file sequentially, one record by record, or you can access randomly each record. So file, soon we will see that the file is made with multiple records. So that's the way that you can access the data either sequentially, or you can do the random access of your data. So a file can contain formatted data, okay, as it would be written onto a monitor. So whenever your monitor displays something, it is formatted, it is readable, or unformatted, meaning it's a raw data. Okay, that means the data which is stored in the memory, that's how the data would be stored in the file as well. So raw data would be very difficult to read by humans. So format is the data, for example, text, the text files usually are very well written, and you can read them easily. Okay, so that is the formatted data, and unformatted data would be would have it would be in the file, but it would have lots of control characters, and it would be very difficult to read. So, for example, those kind of files are also called binary files because they represent the way that the data is written in the memory or stored in the memory. So, for example, unformatted would be Microsoft documents. The Word document that would be when you open it up in some editor. Not with the Microsoft Word, but with some any other editor, it would be very difficult to read because it will have lots of control characters in there with its documents text. Okay, so basically, the Go language provides lots of different packages for processing the file, and that's what we're going to be discussing in this unit. So let's first see how the file is really made. What makes it a file. So basically, a group of related bytes in a field. When you put a group of bytes, that becomes a field. Okay, a field is basically a part of your if, structure, struct that is of some type, and that is one field, and it is made with a number of bytes depending upon what type of that field is. So a group of related field is called the record. So if within a one struct, there could be multiple fields in there, and making of putting those fields together, that makes a record. Okay, in Go language we use the struct for doing that, or even in C and C++ we use a struct as well. Usually one field in each record is represented with some specific field key. Okay, so within a within a struct, you first decide which field will be a key, because the key is the one which will uniquely identifies the record. Each record. So each, if you create how do you create? So one struct instance will give you one record. If you create another instance of the struct, that will give you another record. And so forth. So you can create arrays of structs that will give you the multiple records, basically. So a group related records is a file. So basic idea is that you have multiple records within a file, or I should say multiple records will make a file. So that's how the file is constructed, with multiple records. A group of related file is a database. Now, the term database is very commonly used for storing, all different kind of a data. In corporations, they use different software to create the databases. Now, the database, could have only one file, but in most of the cases, there are multiple files involved in a database. So now, when we talk about the key earlier, key field, so key field will be the one which could be used for connecting the files together to create a database. So that's how the databases are created. Okay. Let's look at how the streaming I/O works in Go language. So in Go language, I/O package. So the Go language provides an I/O package, which has interfaces which we talked about earlier. So these are two interfaces: IO.reader and IO.writer. Okay, for input and output operations. So reader is for input, and for writer is for output operations. So there are many different packages are provided in Go standard library for file operations. So Go language comes with many APIs, meaning that Go language standard library comes with many APIs that supports streaming I/O. Stream. What is a stream? Stream is considered something that goes from producer to the consumer. So that's how the stream, the flow of the data from producer to the consumer. So that's how the data would flow, like a stream of water. A stream of water can flow only in one direction. So the data will be flowing from um, um, uh, uh, the producer to the consumer, so that's how the data would be flowing. So that's why we call it a streaming of the IO input output from the resource, like in memory structure, files, network connections, and many others. So that's how the data flows for these resources. So for network connections, for example, the data would be flowing, from some outside, coming in, and then of course going out again. But still, it will be flowing in the same one direction. It doesn't. Like a data doesn't collide together. It always have some path to it. So, so that's why it is called streaming IO. So the type os dot file represent a file on a local system. So you can use this package, OS package, which has a file. If you are basically working with some physical file on your hard drive, okay, and we'll see that in some examples coming soon. It implements both IO readers. So this os.file represents IO reader and IO writer interface, and therefore can be used in any streaming IO context. So so basically, because this is a interface, then we can use it in any streaming IO context. Like for the in memory or network connection or any other things. So use IO reader and IO writer whenever you are dealing with streams of data. So that's the interface that you should use whenever you are dealing with streams of data. Again, stream of data meaning data going from producer to consumer, just like a stream. Okay, so that's let's look at some concrete example to understand, how the this OS package works. So let's look at the next example here. So write bytes to a file. Okay, how do you write a byte to a file, or bytes to a file? So you use OS package, because this is a package comes with a standard Go library to write bytes. So the bytes can be written to a file. Go provides other IO. Go language provides other IO packages such as IO util and buff IO. Okay, these all other IO packages, and every these packages have its own reasons, or it has pros and cons to use these packages. Depending upon how and what size of the file that you are writing, and so forth. So based on that, you end up using one of these packages. So every package that imports is imported will increase the size of executable. That's the key thing. The size of your program will be increased. It doesn't only relate to the file IO packages. Any package, any time that you import, okay, it will definitely will increase the size of your binary. So binary size will become bigger. So please understand that don't import unnecessary packages that in your code. So the best policy is that if the package provides some functionality that you want to use, okay, and from that package, that functionality you will get it just by calling only one function, okay. So you got to decide if the package size is really big, okay, are you better off importing that package, or are you better off writing 5 lines of code to just to get the same functionality, okay. So I would just write my own 5 line of code instead of importing the package, because I know if the package is going to add, like 100 bytes or 500 bytes to my binary, that is, too many bytes. So and also depending upon where I would be running my code, if it's a small footprint on some device, then I would not want to have a bigger binary size. I would just keep my binary size as small as possible. On top of it, you have to understand also that if the binary size is bigger, then basically what happens is your program, when it is running and it's utilizing the CPU, because that's how it is going to run. It will have to utilize the CPU. So when it is utilizing the CPU, the program is really actually divided into, meaning your binary is really actually divided into, for most of the operating systems, it is divided into 4K pages. So there are pages in the memory. So the some pages, your code might be there in the memory, and some pages might be on your permanent hard drive, or in the some under Linux and Unix they call swap space. Okay, so the things which are needed for that particular program that need to run, and if it is not in the memory, the pages will have to be pulled out from the hard drive or something, and bring it in, and then put it on onto the CPU. So it's a lot of work. And if it is just caused because of the bigger binary size, then it's not good. So that's why I'm saying that it is better to write your own small function than having to import a huge package from the standard library, even, or the worst come is especially from the third party library, because third party libraries are very dangerous to use in some cases, because first of all, they may provide some good functionality, or easy to write the code. You may think that, oh, you wrote the whole Go program, which does very very advanced things in like 300 lines of code. But in reality, since if you have imported the third party library, it really adds quite a bit code, and your binary size will become bigger. Okay, so you need to be aware of all those things when you are writing the code in Go language. Okay, you don't want to unnecessarily make your binary size bigger. So just remember, whenever you import a package, it definitely will increase the size of your executable, depending upon how big the package is. Okay, so let's look at this example 5-7 in this function. I mean, by adding this package main in the code, so we can compile this code, and we are importing these two packages, a log package. Okay, the log package in Go language is provided, so literally you can write log messages to either to a file or dump it onto the display, okay, depending upon how you use it. And then OS package will allow us to basically use files files functionality. Okay, meaning it will let us open the file. So you have to open the file before you can read it. So that's what the OS package will allow us to do. So we get inside the body of a main routine, and at line number 9, what we are doing very first thing is to using the OS package to open the file. The file name is test.txt, and that's the name of the file. And we are saying write, write this file. Okay, truncate, meaning if the file is already there, truncate it and create a file. Okay, and then these are the file permissions. So these permissions basically 666 tells that the file would be read and write. Okay, it will have the read and write permission for the owner and for the group and for the other people. Okay, so that's the only permission it will have. This text file will only be read and write, so you can open the file and read it, and of course write the data and put it back, the change modified file. So that's what it means. At line number 13, os.open will return the file handler under this file variable. Okay, and it returns two values. Okay, one is the file handler, and the other one is if the file had some issues, or when it was trying to open. Okay, and of course it has a short declaration colon equals to, so those return values will be saved into this variable called file and variable called err. So if the file was not open correctly, then this that means there was some error. So as you can see, this we are using the log package, okay, to call the function it has, fatal function, and passing this error, whatever the error occurred. Okay, so if it is not nil, then then that means the error has something in there. If it would be a nil, then it was opened successfully. Okay, so so this function will be called from the log, and this error, whatever the error occurred, it will write it on the display, because this fatal will just dump the error on the display. Okay, now after this check, then as we discussed in the last unit, the defer. Okay, we are saying that defer the closing. So we right after basically opening the file and checking if the file was open, we defer. So basically defer the file until it until or closing of the file is deferred until all other things are done. So the file is not going to be closed at line number 17. Okay? It is deferred, like the way that we talked last time. So it will be closed right before the end of this function body. And then at line number 20, we are creating this variable byte slice. Okay, is of type slice. So we are writing this string into that slice. Okay, so we created the byte slice that has this content, bytes, and the exclamation, and of course it has a new line character in there too. So basically, that's what the slice will have, byte slice. And then at line number 22, bytes written. Okay, so now we are calling the write function from the from this IO package. Okay, so we open the file name. The handler is here. File is a handler. So we're using the file handler to call this write function. Okay, and then giving this a slice to write it to a file. Which file that it is going to be writing? It is going to be writing it to the test.txt. Okay, once it has written, or once it try to write it, and if it succeeds, then it will be nil. Error will be nil if it succeeds. So that means everything went okay. If it doesn't succeed, then error is not going to be nil. It will have some value. Okay, but this write function returns two values, error and the slice. Okay, so it returns two values. So basically, uh, that's what the write function does. And in this case, after writing it, it it tells us, how many bytes are written. So this it bytes written is the value that we get. So basically, it is an integer type. So this type will be created automatically because we are using colon equals to, which is going to create a memory based on what type was written. Okay, so that's going to be an integer. And then we check again if if the file was opened successfully or not. If not, then the fettle will be called. And then if it was, then what we're doing right here is to log.printf. So we are basically calling the this printf from the log function. Not now. Notice that this is a log package. Okay, we are using a log package. So basically, in this case, it is just going to dump on the screen. But notice the difference. If I would have used the FMT, then I would have just got the this 7, and then of course this whatever the string right would be, then it would print that. But if you're using this log, then it is actually giving you the timestamp. Okay, this is the timestamp. So that's the major difference between FMT print f and log.printf. Log.printf is logging with the timestamp, and of course it is telling you, whatever you have it within this string as well. So that's the difference in between, using the printf from the FMT package or from the log. Okay, that basically concludes the concludes our um, unit 5, chapter 5. Okay.